Okay, so object definition language or ODL is actually used to create the database schema, just like we have data definition language DDL in the case of relational database. Here we have got ODL. So here we look at an example. So if we have an ER diagram like this, okay, this is an extended ER diagram for a university database. So how can we write the ODL for this? Okay, so if we look at this, so here we have a person. Person is the object at the highest level of the hierarchy, and then we have faculty, which is inherited from person, student inherited again from person, and grad student inherits from student. And of course, these relationships as well as the relationships between the different entities also have to be represented. Say, for example, faculty works in a particular department. All those information also have to be specified, right? So how is it specified as part of ODL? Okay, so here, look, class person. Okay, person is at the highest level of the hierarchy. We have got an extent. Extent is consists of all the persistent person objects, right? And there is a key also associated with that particular extent. Now, all the attributes which are given as part of our ER diagram. Generally, when you draw an ER diagram, there'll be each entity will have an attribute. So those attributes have to be listed here. So first one is name, right? Name itself is made up of first name, middle name, and last name. So that is represented using a tuple or a struct declaration. Okay. Similarly, other attributes are social security number, date, gender, and so on. So similarly, again, address is also a it's not multi attribute, right? So, or a composite attribute. So that is also represented using a tuple or a struct and so on. Now, faculty extends. This is an extend, and this is extends is for inheritance. Okay, it extends person, which means all these attributes will come here also. And if we look at this faculty, if we look at this faculty works in a department. So how are relationships represented? Apart from attributes, you have relationships also. So relationship works in the department. That is a relation. Faculty works in the department. That is the forward relationship. The inverse relationship will also be represented. So if we look at this, department has faculty, which will be a set of faculty, right? Similarly, relationship advisors, that is another relationship because faculty advises graduate students. So, in this relationship, faculty advises not just a single student, so you have a set. So, when you have one to n relationship, right? When the n side is stored here, you need a set. Similarly, the inverse can also be so. That is, grad student has an advisor, right? So this is how we represent the different attributes and relationships, and we also need to represent the different types of operations on this also, right? Okay. So another thing is we said relationships can be represented in some cases. Excuse me. Some cases when you have an M2N relationship. Say for example, uh, say you have department offers courses, right? And courses are again divided into sections, and the student belongs to a section, or a student actually enrolls for a course through this section. Now, what happens is if at all there is in this relationship, if it has, now generally it can be represented using the relationship here, and with the n side actually represented using a set. But when there are attributes associated with such relationships, then we go for a separate class for showing this relationship. Say for example, grade. So a student, that is a student has or enrolls in a particular course or a particular section of the course. Okay, a student enrolls for a particular section of a course, and for that uh, enrollment, a grade is also associated. So in that case, right? So it is an M2N relationship. If you look at this, a student enrolls for a course through the section, and a course can have multiple sections. Okay, multiple students in a section. So here this is N way, and similarly student can have multiple sections also. So it's an M2N relationship, and then uh, when attributes are associated with it, we come up with what do you say? A class. Okay, it's not part of a part of another class. Okay, you define a separate class for it. Okay, so this is how ODL is used for uh, what making our declarations, right? Okay, so object database conceptual design. What is the relationship difference between object database and relational database design? So one is how relationships are handled. In the case of ODB, relationships are represented using the OID. If, say, for example, we have faculty works in a particular department, so this department is actually represented using an OID, object ID, right? In the case of binary relationships, references in either direction can be specified. That is, inverse can also be specified. Now, M2N relationship with attributes are represented using a separate class. Similarly, for we were talking about binary relationship, n-ary relationship can also be represented using a separate class. Okay. In the case of RDB, of course, the relationships are represented using foreign key constraints, and M by N relationships are represented using a separate table. Inheritance mechanism is not present in relational databases, but here you have got two types of using this colon as well as extends. Both can be used for inheritance. ODB operations, okay, in case of operations in the case of object databases, they have to be specified as part of okay, operations are also specified as part of the class or interface, but in the case of relational databases, when we go for the declarations, we do not think about operations, but it can be delayed. We can think of operations even later during the implementation phase. Okay, how do you map from an ER schema or ER diagram to an ODB schema? So create an ODL class for every entity type. In the case of RDBMS, for every entity type, we create a table, right? Here we create a class. So all attributes in the entity should be included in the class. Multi-valued attributes are declared as set, bag, list, constructors. Composite attributes are represented using tuples or struct. And you can have uh, declare extents, that is multiple persistent objects can be declared for a single class. Now add relationships as reference attributes. Okay, that we have already seen. Relationships may be in one or both directions. Binary relationship in both directions can be specified using inverses. And now in the case of okay, one to one, n to one, etc. One to one, you can use the object IDs to represent the relationship, and part can be used represented using the collection type. Alternatively, M2N relationships can be represented using class, a separate class, and so on. Okay. Mm, and similarly, operations have to be included. That is there. An ODL class that corresponds to subclass in ER schema inherits the attribute relationships and methods. So inheritance is supported. Now weak entities can be mapped in the same way as regular entity types. That is, we can create a class, or alternatively, weak entity types if they participate in a relationship only with the identifying relationship. Okay. Okay, so weak entity types can be mapped in the usual way, or it can be represented as part of the corresponding strong entity type. Okay, and also n-ary relationship, that is with degree greater than 2, can be represented uh, not as part of the class itself, but that relationship itself can be represented as a separate class. Okay, so this is how we map. So for every entity type, we have a class. And സാധാരണ നമ്മൾ RDBMS map ചെയ്യുന്ന പോലെ attributes are mapped into attributes here. Multi-valued attributes are represented using set. Composite attributes are represented as tuple and so on. Relationships can be, if you have a binary relationships, 1 to n, 1 to 1, 1 to n, and n to 1 can be represented as part of the class itself. But M to n relationships, if it has attributes, then it has to be represented as a separate class. Operations are also specified as part of the class itself during design itself. And if inheritance relationships can be represented, weak entities are represented either as part of the strong entity to which it is related, or it can be separately represented as a class. And an n-ary relationship is represented using a class. So this is a general mapping mechanism.